Hey, algebra. So here's the do now. Go ahead and hit pause while you finish. Wow, that was so fast. Nice job. So slope and the y-intercept out of that equation. Slope is going to be the green one. That is -3/2. The y-intercept is the blue one. That's the +4. And we can always recognize slope. It is the number touching the x. And even if the equation gets mixed up, it's still going to be the number that is attached to the x. So if we want to graph it, we're going to start from the y-intercept. That's the 4 on the y-axis. Count up 4 spaces to find the 4. And then from that blue dot, MathCat's going to use the slope to find the next dot. We're going to go down 3, down because the negative, down 3 spaces, and then to the right 2. We always run towards the right. And there's your next dot. Hey, so today we are going to do a little bit of recapping. We have studied so far 3 different forms to write the equation of a line, and today we're going to be changing between forms. So there's 2 parts to the learning target. First, we'll have to be able to recognize those different forms, the 3 different forms. And once we can recognize them, then we'll be able to say, oh, this is this form, I need to change to that form based on what the directions are telling us. So the first form we're going to talk about today, slope-intercept form. We've seen this before. I'm going to go through these one at a time. So we put 3 different subcategories together when we were learning to graph in slope-intercept form. The first one was a vertical line, x equals some number. I gave the example of x equals 2. That is a vertical line. We can totally graph it. Um, it's got an undefined slope. And if the slope is undefined, what that means is in mathematical terms, the slope does not exist. And if there is not a slope, then you really can't have slope-intercept form, right? Because there is no slope. So since the slope is undefined, this type of equation, while we can still graph it, is not slope-intercept form. It's just a totally separate thing and does not belong in this category. A horizontal line like y equals -3 or y equals any other number has 0 for the slope. And we could put this in y equals mx plus b form. That is what slope-intercept form is. We just have to put a 0 into the slope spot, like I have written right here in purple. Um, we don't hardly ever do that because there's a lot of extra writing, and so we don't see that very often. But it illustrates the point here that this is, in fact, slope-intercept form. It just has a slope of 0. And so typically we leave the slope out, and you just have like y equals -3. You have a horizontal line, that counts as being part of slope-intercept form. And then, of course, if we had y equals mx plus b, that's typically what we expect when we're talking about slope-intercept form. That is slope-intercept form. So I give the example of y equals -3/4 x plus 5. You can see both the slope here as a fraction in blue, and you can see the y-intercept circled in red. You could have positive slope or negative slope, fractional slope, whole number for slope. Doesn't make any difference. Your y-intercept could be positive, could be negative. It could, in fact, be 0. You could have 0 for a y-intercept. That would still count as being slope-intercept form. And then lastly, we can take slope-intercept form and rewrite it using function notation. And so I've given some examples down here at the bottom where instead of that y at the beginning, we've replaced the y with f of x to indicate that this is a function, which is a super important connotation when we're studying algebra and advanced math beyond algebra. We need to know that things are functions and when things are not functions. And so a lot of times we'll use function notation. That doesn't change the fact that this is still slope-intercept form. We can change the letters, use a different label, like the second one, a of t. So maybe there's some reason why we want to call this function with the name a instead of just using an f for function. And maybe there is some reason why we have changed the variable to a t instead of an x. Maybe it's the amount of people as a function of time, right? As time goes by, the number of people in the room changes or something. And so maybe it makes sense based on the context that we do want to use different labels and different variables. Okay, maybe not. Who knows? And then the last one, f of x equals b. That is still going to be our horizontal line and is still an example of slope-intercept form with a 0 slope, but written as function notation. Okay, second form we're talking about today is standard form. Standard form typically is written as ax plus by equals c. The a and the b are going to be numbers. They could be either a positive number or a negative number. They could be whole numbers or fractions or decimals or whatever. Typically, they're whole numbers. That's kind of the grammar of standard form, as we write it so that everything will be a whole number. It could be positive, could be negative. And the easiest visual cue to recognize standard form is that both the a term and the b term are going to be together on the same side of the equal sign. So I gave an example here of 2x minus 4y equals 12. You can see that the x and y terms are both together on the left-hand side. So that's our giveaway that this is standard form. And typically, if we're changing forms, the most common thing that we'll do is take some other form, like standard form, and change it into slope-intercept form. So I'm going to take that same example equation that I just wrote there, and we're going to rewrite it into slope-intercept form. So slope-intercept form, of course, means it's going to be in y equals mx plus b form. And so in order to get this equation rewritten into the y equals form, it's going to take us 2 steps. We're going to do all of the steps of solving that we've learned in the past to get the y by itself on one side of the equal sign, and we're going to use opposite operations to cancel all of the other parts of the equation away from the y, and so they're going to move to the other side of the equal sign. So our first step is we want to get rid of this 2x. So I'm going to subtract 2x on both sides of the equal sign. These are going to cancel. I'm going to drop down this minus 4y. I'm now going to call it a negative 4y equals. And then on the right-hand side, that 12 and the negative 2x, those are not like terms. So we cannot combine them. A lot of times people will try to subtract and be like, oh, 12 minus 2x, that's like 10x. It's not. Okay, they're not like terms, so we're just going to have to write them both down. And you can write them in either of these two orders. You could put it equals 12 minus 2x, which is kind of the way it seems like you should write it. But sometimes we want to have the x term written first and then the constant afterwards. And so it might be advantageous sometimes to put the negative 2x first and then the 12 afterwards. And we have to put a plus or a minus between these terms to keep them separated. So since this was a positive 12 to begin with, we're going to fill that in with a positive 12. Okay, I'm going to go ahead and proceed with the blue version since that is now at the bottom of my screen. It's going to be easiest to keep working with. So my second and final step here is, let's get that out of here so we're not confused. My second and final step is going to be to divide by negative 4. So I'm going to write the division with 2 different ways to write the divide symbol, and just so we can see them both. So the negative 4 is going to divide by the negative 4 to get 1. The y is still here. Equal sign comes down. And then on the right-hand side, there are 2 terms, and I need to divide both of them separately by negative 4. Okay, and we don't have to worry about like terms when we're dividing. So we're just going to divide negative 2x, divide by negative 4. I'm going to do this mentally. This is like a fraction. Negative 2 divided by negative 4. It's going to give me 1/2 x. And then the second term there is the positive 12. I need to divide that by negative 4 also. 12 divided by negative 4. It's going to be negative 3. Blam, done. So I've taken what was in standard form originally, 2x minus 4y equals 12, and in 2 steps, plus 1 explanation, I changed it into slope-intercept form. Okay, lastly, the last form is called point-slope form. Typically, we'll see that written. The general version is y minus y1 equals m, and then parentheses x minus x1. I give an example with numbers filled in there for both the point and the slope. And the easiest way to recognize point-slope form is it's the only one that's going to have parentheses. So if you see parentheses, this is probably point-slope form, unless it's just some screwy thing there's not anything, but it has parentheses anyway. If it got parentheses, it's going to be point-slope form. And again, if we need to rewrite this equation into point-slope form, from point-slope form into slope-intercept form, then it's going to take us 2 steps. There's going to be a couple of different steps this time because we're coming from a different place than what we were last time when we looked at standard form. So step number 1 is to get rid of these parentheses. I'm going to take this -2 and I'm going to multiply it onto both the x and the 4. So y minus 1 equals, that all comes down, and then in red, -2 times x, that's -2x. And in green, -2 times 4, that's -8. Okay, and then my last step is I need to get the y by itself. So in order to get rid of that 1, the -1, I need to do the opposite operation. So I'm going to add 1. I have to do the same thing on the other side of the equal sign. So I'm going to add 1. We do want to make sure that this +1 is lined up underneath the like term. It needs to go underneath that -8. It can't go underneath the -2x because it's not an x. So we're going to keep it with the like terms. Okay, these cancel. Y equals -2x. -8 plus 1 is going to give me -7. Blam. All right.